Good day, everyone. Dr. Simmons here with a new video, and I come to you straight from class. I actually have the same attire that I wore to class, and I decided to go ahead and record a video because I feel like I need to make a new video on how to find a vertex of a quadratic function. I just feel like I need to get on here and do that. Over time, especially when you're teaching, you find new techniques that are um more beneficial to students, I feel like, or it may be a new option for students. I don't want to use the word that is easier or harder or whatever the case may be. I just want to show you another method. So I want to take some time today to show you this new way to find the vertex of a quadratic function, and also how it can help you find the range. We all know the domain of a quadratic function is negative infinity to infinity, all real numbers, right? But the range can change depending on how it shifts up and down, right? So let's start out with this, the standard form of a quadratic function, right? So I'll put it like cling, cling, cling. We'll put it right here. Standard form of a quadratic function. If you look at it, you can't tell how much is shifted up or down. We call that a vertical translation, right? We don't know if it goes up, we don't know if it goes down. You can't see that without graphing it, right, in a graphing calculator. So what we can do is change the way it looks so you can look at it and instantly say, oh, that goes up 4, or oh, it goes down 7, whatever the case may be, right? And you can also tell whether it goes left or right if we change the form. With it being in standard form, I can't tell any of that. I don't know if it's going left, right, up, down. I don't know anything like that until I change the form. So when you find the vertex, you can change it to a different form that looks like the vertex form. I guess that's what we'll call it, right? I don't even know if it has a name, but I call it the vertex form of quadratic function, and it looks like this. Bling. This is like the vertex form of the quadratic function. Call it the vertex form because, hey, I can look at it and instantly tell what the vertex is going to be, unlike the standard form, right? So this is what this video is all about. It shouldn't take too long, so y'all be patient with me, okay? All right, here we go. Okay, welcome to my iPad. So, I want to get into this conversation about the vertex form of quadratic equation. So I have this little carousel thing, this little direction thing that I have here. It's just to help me organize my thoughts. But I'm going to put over here the standard form, which I talked about just a few seconds ago. So this is standard form. And what I said about the standard form was that, hey, I can't look at this and tell, like, if it's going up, down, left, right. I can't tell any of that by looking at the standard form. Now, there's a lot of use for the standard form. We use the standard form to, like, if we need to factor or something like that, or combine like terms. But standard form doesn't tell us really too much about how it's shifted, and it doesn't tell us where the vertex is. We're trying to get it into this form called the vertex form. And so I'm going to put that down here. I'm going to skip a few steps because I want to show you my end game. So this is kind of like your vertex form. Okay, so let me point out some stuff. So the A that you see is the same A from the standard form. If you go back, it's the same A that's in the standard form. That's not going to change. Okay. The H and the K. So the H and the K represent your vertex. So once you find the vertex, you put the numbers here and here, and then you'll have your vertex form. So your A is from the standard form, and then you find your vertex and put it in for the H and the K. All right. So boom, I have all that. That's what we're trying to get to. We're starting from standard form. We're trying to go to vertex form. Okay. So let's talk about it. Let's talk about how to find the vertex. So let's go back here to our standard form, right? So to find a vertex, as I said before, the vertex, we usually use the variables hk to represent the vertex. So h, to find h, is going to be negative b over 2a. So that a and the b come from the standard form. So you take the number that's representing a, you take the number that's representing b, and you plug it into the formula. And that will give you your first coordinate in your vertex. Now this is generic. I am going to use this idea and go down to this example so you can see what I mean. Have to grab something real quick. Okay. So you see the example at the bottom, right? I'm going to use that to help me to an example. So this is your standard form. This right here is written in standard form. I want to find the vertex. The vertex is hk. So to find h, I'm going to take negative b over 2a. So your b value is negative 12, but there's a negative in the formula, so be careful with that. That's one of them dangerous things, those negatives. So you got the negative, and then your b value is negative. So that's gonna turn to a positive eventually. And then you have 2 times your a value is 3. Okay, so you have 12 over 2 times 3 is 6, and then 12 divided by 6 is 2. Okay, I found the first coordinate in my vertex is 2. All right, now to find k. So we know how to find h. Let me go back up here and talk about how to find k. So to find k, to find k, all you have to do is take that value that you found for h and plug it into the function. All right, that's the generic form. Let me go down to the example so you can see what I mean. So you take the value for h and you plug it into the original function. So let's do that here. I have k, f of the value that I found was 2. And so that means I want to plug in 2 for all of my x's. Okay, and then I'm cleaning this up. That'll be 2 squared is 4. 4 times 3 is 12. Let me just write this out. Since, it's a video, might as well write it all the way out. All right, so I got 12 minus 24 plus 5. So your final answer is going to be negative 12. There'll be negative 7, right? No. Yeah, negative 7. I just want to make sure, because that'll be negative 12, and then negative 12 plus 5 is negative 7. Okay, so your vertex is 2, negative 7. Boom. That's your vertex. So if I wanted to change this standard form to vertex form, it would be f of x. Your a value stays the same. That'll be 3. And now I have h minus k. X minus h. I said that all wrong. It'll be x minus h. So x minus 2 squared. And then the k goes at the end. So that's minus 7. And this right here is your vertex form. Notice I put the 2 in for the h, and I put the negative 7 in for the k. Remember right here, this is the h, this is the k. And now I have my vertex form. And when I look at my vertex form, I can tell, oh, okay, this is a parabola that's going to go down 7, and it's going to go to the right 2. And if you need to know more about like how parabolas are translated, like if it goes up and down, left or right, I have a video about that. I'll just put it in the description. Okay, so that's how you find the vertex. You know what I'm gonna do? I'm going to do another example. Is that smooth? Let me do another example. Do it here. All right. I feel like 1 is too easy. Let's go to number 3. No, 1, your A value is, for number 1, your A value is 1, your B is -6, your C is 7. I'm just, for the sake of time, I'm going to try to work some that are a little bit more, okay, got a little bit more to it. So this is number 2. I'm looking at number 2. I'm trying to find my vertex, HK. Now this is my vertex. Don't get this confused to the H that's in the function. That's just the function. So H is equal to -B over 2A. So -B, your B value is -4. Again, you got a double negative there. And then you have 2 times 2. So this is going to turn into +4 at the top. And then 2 times 2 is 4. So this turns into 1. Okay. Now I have to plug in X into the original. Again, don't get that H confused with the H that's in the formula. So I plugged in 1 wherever I saw X, and now I need to simplify. So this is 1 squared times 2, and then 4 times 1, that's -4, and then +5. So this is going to end up being -2. This will be 3. So your vertex is 1, 3. This is your vertex. If I wanted to rewrite this in the vertex form, it'll be 2. That's your A. And then you got to do X minus H. So X minus 1 squared. And then you put the K value at the end. So this is +3. Boom. Okay. I'm going to do the next one just because I think it turns out to be a fraction. I'm going to do a different color. I'm going to do a pretty color. Okay. So H, what are we trying to do? We're trying to find the vertex. So that's -B over 2A. Notice how I keep writing the formula. I keep writing the formula, and I say this in class all the time. If it is an equation there that you are not familiar with, write it before you use it, because it does help. I did something wrong, did I? Yes, I did. Yes, I did. Because I was talking. Your A value is 3, right? Thank you. So 2 over 6. Because at the top, it turns into +2. And at the bottom, you got 2 times 3, which is 6. And then this can be reduced. Always reduce. I get 1/3. So it's okay. If you get a fraction, it's not the end of the world. I know people hate fractions, but fractions happen. So I put in X is equal to 1/3 minus 2 times 1/3 plus 1. And so what I typically do is I go ahead and put this in the calculator, in my graphing calculator. I don't have it up right now, so I'm just going to try to do this by hand. 2 over 3 plus 1. So when I multiply these together, I get 1/3 minus 2/3 plus 1. So what do I get? I got equal signs all over the place. So this is -1/3. 1/3 minus 2/3, that's -1/3. And then plus 1, that'll be 2/3. Yep. So your vertex is 1/3 and 2/3. And if I wanted to write this, I'll change the color so I don't get it all confused. If I wanted to write this in vertex form, your A value is 3, and then you have X minus H, and then you tag on the K value at the end. And this is your vertex form. Again, it tells you more about what's going on than the standard form. It tells you how the vertex goes up and down, left and right. Let me scroll back up to our little carousel up here. Okay. So I skipped around a little bit, right? But I know how to go from 1 to 4 by using step 2, right? So I got my standard form right here. I use the vertex and put it in vertex form. Boom, I got that. Now let's talk about the axis of symmetry, which is super simple. Trust me. So axis of symmetry is when you have a parabola. Boom. You have a parabola. Axis of symmetry is just this line that goes right through the middle of your parabola, no matter where it is. It's a line that goes right through the middle. They call it the axis of symmetry because if you go right down the middle of the parabola, it's the same on the left and right, right? So that's why they call it the axis of symmetry. But if you find your vertex, you already have the axis of symmetry. The axis of symmetry will be your H value because your vertex is right here, right? Your vertex is going to be HK. So if you want the line that goes through the middle, it's a vertical line. And every vertical line is going to be X equals something. Every vertical line. So once you find your H with your vertex, you already have the axis of symmetry. It'll be X equals H. Again, this is the generic form. So let me go down to the example. That's the generic form. Let me go down to the example. So in this particular parabola, my axis of symmetry, will be X equals 2. That's all I have to write. Because it's always going to be the H. Okay? What else can I fill out here? So concave up, concave down. Most students understand this, but let's talk about it. So concave up, you always look at the A value. So if your A value is positive, in other words, if your A value is greater than 0, that's another way to say positive, then it's going to be concave up. I think we kind of know that, right? But if the A value is negative, in other words, if A is less than 0, then it flips the parabola, right? It's going to be concave down. We kind of knew that before we even got to this section. But in case you need it written down, you have it written down right there. And so now let's talk about domain and range, and then that will sum up the video. So domain, your domain, if you're talking about a parabola, it's always going to be negative infinity to infinity. I mean, there's no restrictions. When you look at the equation, there's no restrictions. And also, when you look at a picture, I mean, a parabola is a U shape, right? It's a U shape. It looks kind of like this. Or it could be concave down like this, right? It's still going to be negative infinity to infinity, whether it's concave up or concave down. Now, your range is when things change. And it depends on if it's concave up or concave down. Now, if you have a parabola that's concave up, like this one right here, then your range is going to be whatever your K value is to infinity. The K value really helps you understand what your range is going to be. This is only if your A is greater than 0. So that's a lot of letters there. So let's go to an example, right? So if you go down here to this example that we did at the bottom of the page. So your A value is 3, right? That's a positive number. That's going to be a parabola that's concave up. So my range, if I wrote it over here, your range is going to be bracket, what do we have? -7 to infinity. I use the K value. The K value is -7. That's the very lowest that this parabola is going to go. But then it goes up to infinity because it's concave up. So that's why it starts at -7 and goes up to infinity. Your domain, I'll go ahead and write that here also, will be -infinity to infinity. Boom. However, if the A is less than 0, if it's negative, then it flips around. You're going to go from -infinity to K. So like an example of parabola is concave down, you see you look for the lowest value, it goes down forever. That's negative infinity. And then it goes up to wherever the vertex is, which is K. Okay. So I think you have everything you need. We went around this whole carousel. I'm going to split this up. Got some powerful information in here. Now you know how to go from a standard form to a vertex form. And also you know how to find the axis of symmetry, domain, and range, and whether it's concave up or down. So I felt like I went through that pretty fast. So you know what I'm going to do? I'm going to go through an example. And I'm going to take out my calculator just so I can go through this a little faster. Okay, so vertex. So this is, I'm just going through the example, right? So I have your parabola up here at the top, and they're asking me all the things. So I'm going to go through one at a time. I'm looking for your vertex. The vertex is going to be the negative b over 2a. So negative b, my b value is 4 over 2 times negative 3. So that's going to be negative 4 at the top and negative 6 at the bottom. I do have a negative over a negative, so it turns into a positive. And then the 4 over 6 reduces into 2/3. Okay. Now I'm going to find my K by plugging in that 2/3 for all of my X values. And this, I'm going to plug this into my calculator so I can see. You know what? Actually, let me pull my calculator up. Okay, let's look at here. It was 2/3, right? Oh, clear. So it was negative 3, parenthesis, and then we had, I'm going to put my fraction bar there. We had 2, 3, and then I'm going to close the parenthesis, square. And then we had plus 4, parenthesis. Let me put another fraction bar there. 2/3, close parenthesis, plus 1. And then they didn't put it as a fraction, so I'm going to put it in the fraction notation. 7 over 3. Seven over 3. All right, so your vertex is 2/3 and 7 over 3. Boom. All right, now my axis of symmetry is going to be whatever your H value is, right? So X is equal to 2/3. That's it. That's your axis of symmetry. And then is it concave up or concave down? It's actually your A value is less than 0, so this is actually concave down. It's a parabola that's going to be concave down. All right, so now let's talk about the x-intercept. So I have a video on how to find the x-intercept. Let's do it for this one. To find the x-intercept, you set your y equal to 0. And I mean, for a function, f of x is like saying y. So that's what you're replacing the f of x with 0, basically. So I'm going to go over here in this empty space over here and see if I can work this part out. So 0 is equal to negative 3x squared plus 4x plus 1. And so I need to solve for x. And first I'm going to try to factor it. And what I notice is I get negative 3. I'm trying to find two numbers that when I multiply, I get negative 3, but when I add, I get 4. And there is nothing. I can multiply to get negative 3 and add to get 4. So that's not going to work. So what I'm going to have to do to solve this quadratic equation is use the quadratic formula. And that happens. That happens sometimes when you have a quadratic. equation and you can't solve it or you can't factor it, you got to use the formula. So this will be negative 4 plus or minus the square root of 4 squared minus 4 over times negative 3 times 1 over 2 times negative 3. Okay. So now I got to clean this up. And I'm actually going to pull... Can I split screen and put my calculator up here? Oh, yeah, it would let me... Thank you. Thank you. Okay. So now, let me show you how I clean this up. So I'm going to take everything that's underneath my radical. Okay, I put everything that's underneath my radical, and I try to figure out what that is, and it's 28, right? So now I'm going to clean this up. I get 28. So negative 4 plus or minus the square root of 28. And then at the bottom, I can do 2 times negative 3 in my head. That's going to be negative 6. All right. So the square root of 28 is not going to be a whole number because, you know, it's not a whole number. It's going to give you a decimal if you put it in your calculator. So that means you got to clean up 28. So 28, we're going to break 28 up. I'll do it over here on the side. 28 is going to break up into 4 times 7. So take the square root of the 4. It comes out of the house. I can't take the square root of 7, so it stays in the house. So let me put the changes that I did over here. So this is negative 4 plus or minus 2 square root 7 over negative 6. And the last thing I got to do is reduce because all the numbers on the outside can be divided by 2. So negative 2 plus or minus the square root of 7 over negative 3. And if you want to, you can get rid of that negative on the top and bottom. So that, I mean, you can only get rid of that negative because you have that plus or minus there. So don't just think I have a negative 2 over negative 3 and I'm canceling those out. I'm able to do that because I have that plus or minus there. And it kind of makes that square root 7 plus or minus as well. All right, so that's going to be your x-intercept. It looks weird, but that's what it is. I can get rid of this calculator, right? Okay, so 2 plus or minus square root 7 over 3, 0. The good thing about the y-intercept is that's just when x is equal to 0, and usually that works out a lot nicer because the zeros make everything cancel out. You just get y equals 1. Move this out the way. So your y-intercept is going to be 0, 1. Okay, let's talk about domain and range. Domain, we know is going to be negative infinity to infinity. And then your range, because it's concave down, you start with negative infinity, and then you go up to 7 over 3. As you saw, that's what we use the k value in your vertex, remember? Right here. This is your vertex. And we use the k value to find your range. And now, lastly, I got this increasing, decreasing. Let me talk about this real quick because I know this is kind of weird. So this is a parabola that's concave down. It's not to scale. I'm just doing this. It's not, please don't, it's not to scale at all. So this is going to be, the vertex is 2/3 and 7 over 3. That's your vertex. So you're trying to find where on this graph is it increasing, the x values, where it's increasing and decreasing. I always do this thing called going up the roller coaster, going down the roller coaster. So from left to right, you're always reading from left to right. So if I start on the left-hand side and I'm going like this, that's going up the roller coaster. So that's increasing. And that's going to go from negative infinity to 2/3. That is all increasing. Then from here to here, I'm decreasing. Pretend like that says decreasing. So from 2/3 to infinity, I'm decreasing. And it's just, you're just trying to figure out where on your parabola are you increasing and decreasing. That's all that is. It's just something like that that's kind of in my math lab, or it may be. But that sums up my video. I hope that wasn't too long. But this right here is really the main thing you need to know. I'm going to erase this right here. You need to know how to go from standard to vertex form, and then you got little things here and there that you may need to know, like the axis of symmetry, concave up or down, domain and range. And all of that can be found once you find the vertex. Now, I hope this video was helpful for you. Boom, I'm gonna put a smiley face here. Y'all have a good day.